Hello and welcome to Education at SSBJ online video tutorials. In this video tutorial, we are revising all the ray diagrams which are important as far as your periodic text 1 is concerned. Ray diagrams are basics of this light chapter. Once you become familiar with the ray diagram, then most of your problems understanding will be more clear even in future, that is in higher classes. So it is required to set the skill of ray diagram in the beginning. So we shall take up 3 or 4 questions in this tutorial and see how we can draw that. When the mirrors are arranged in such a way that they have 90-degree angle between each of them and given an incident ray which is making 50-degree angle with the plane of the mirror, this is 50-degree. You have to show the path of reflected ray in both the cases of mirrors. Why I am telling this? Because it reflects here and hits here and then it again reflects here. So the path of the incident ray changes here because of the reflection. You have to use proper procedure here. Apply law of reflection, find out what is angle of incident and angle of refraction in the first case, this one is here, and also in this case 2. Complete the diagram. This diagram may be of 3 or 4 marks for class 8 standard. Now how will you go for it? You have to keep a protector here, right? And then see what is the normal here. This is supposed to be normal. And what is normal? Normal is perpendicular. Right? So this is the normal. Between normal and incident ray, how much is the angle? So it is here 10, 20, 30 and 40 degree angle. That means if angle of incidence is 40 degree, angle of reflection also will be 40 degree. So here 1, 2, 3, 4. Our light ray will reflect in this direction. But it doesn't stay there. It will go and hit on other side. Right? Here the normal also you have to draw. Now coming back to this surface now. Coming to this surface. You have to again pick up the protector and keep it there and first draw the normal. And again normal is 90 degree to the surface of the mirror. Right? Now find out the angle of incidence here. And what is angle of incidence? Angle of incidence is 10, 20, 30, 40, 50. Here it is 50 degree. Here it was 40 degree. Right? And so as here angle of reflection was 40 degree. Now if this is 50 degree angle of incidence here, angle of reflection also will be 50 degree. So 10, 20, 30, 40, 50. So our reflected ray will move in this direction. In this direction. 10, 20, 30, 40, 50. Yes. Yeah. So it will move in this direction. Right? This is what the diagram which you have to draw and write all the values here. This you have to actually practice it on paper and keep ready as your assignment. Right? So you have to complete here, write here 40 degree and 40 degree here and then here 50 degree and 50 degree. Okay? And these two are the mirrors. Right? And what was the angle given here? Angle given here was 50 degree. So this is a plane mirror this side is a smoother side and this side is a rougher one where image is not seen, right? So take up the paper, okay? Your work also should start along with me now. Wherever you want to pause it, you can pause this video and continue. That is good for you. Now, as far as drawing is concerned, what you have to do is you should have a scale as well as a protector, right? Take this mirror somewhere in the center and you'll come to know why I am drawing this in the center. And keep an object, okay? And call this as, let us name this object as AB. Now henceforth we will call this arrow mark, the standing arrow, vertically standing one, is an object, right? And now we shall apply laws of reflection. Now you remember, all that light ray which falls on this object will reflect back. So from this particular point now, we'll pick up two light rays, and again from this particular point we'll pick up two light rays. Let's understand how to draw the ray diagrams now. Let me pick up one light ray here. Now a light ray which goes from this bottom, it hits here on this mirror, and since this is falling on the mirror with a 90 degree, right? What will happen? What about the reflected ray? Right? Reflected ray will go back in the same direction. In the same way, from this point, if a light ray moves straight and falls at 90 degree angle here, what will happen to the reflected ray? It again goes in opposite direction, right? Now, two rays we have taken and they go back. One more ray we'll take. It doesn't mean that only the light rays will go straight onto the mirror. Some light rays will go in a different direction. Let us take one of those light rays. Another light ray will go from A to this particular point here. And now we have to draw the reflected ray. It was easy to draw the reflected ray here because it was along the incident ray. But here what we have to do, we have to find out the angle here. Okay, we should find out the normal here. This itself becomes the normal. That's why I have taken the background of your notebook so that these lines you can make use of. So we have to find out what is the angle here. We have to find what is the angle here and then measure that much of angle on either side and draw the line. Okay, that you all know how to do this. So we have applied law of reflection. And what is law of reflection? Angle of incidence is equal to angle of reflection. Now the next part is to draw virtual light rays. Virtual light rays. Now this is a real light ray. It actually going and coming back. So its image will fall backside, isn't it? Now whenever you are drawing an image, so you have to put that in dotted. So this is dotted one line. Otherwise you cannot make a difference. If this is a real line, this is a virtual line, right? It's an image. So in the same way here, this particular line will have an image somewhere here, right? So you have to extend this backward. Now what will happen here then? You have to extend in this direction only. So it meets somewhere here. Now look at this. Two light rays gone from here, from this point, and they are meeting somewhere here, right? So the image of this particular point will fall here. If the image of this particular point falls here, so image of all these points will fall below it, isn't it? And that's why you can straightway draw the image. Now look at this. I have drawn image again dotted. So that's how you can make a difference between an object, this is object, and image. Right? You should take care of that. Now we have to verify this. Right? And we know that the distance here between the object and the mirror and mirror and the image should be same. And if by mistake, if it is not same, you will not get marks for this. It becomes simple drawing, not the answer. So you have to take a scale and find out. So this is around 7 centimeter, and then you click it on other side and see that this is also a 7 centimeter, right? So our diagram is correct. If this type of diagram you draw, then you will get full marks. Okay, so that is why you have to practice this. Sometimes what happens, because of our mistakes, the image will sometimes move on other side. It comes maybe nearby or far. So that time, as far as evaluation is concerned, you will not be getting marks, right? What happens, let me tell you. So children will draw this here, and then these things properly they draw. Incident ray and it reflects back. Again, this ray goes here and it reflects back, and then it is extended on other side. Okay, what about this ray? This ray, they make a mistake in calculation of angle and applying angle and angle I and angle R should be same, isn't it? So if they make mistake here, and suppose if they consider that this angle is little bit bigger here by mistake, I am telling. So what happens when you extend these light rays, this light ray will go and meet somewhere here and the image will fall somewhere here. So the distance you see now, distance is different, and this diagram is a wrong diagram. Okay, so you have to be very careful when you draw the diagram. I am sure you will draw this 2 to 3 times. What is the question? Draw the light ray diagram of formation of image of an extended object in the plane mirror. Now we have to draw a ray diagram. And what should we have to draw the ray diagram? A notebook and compass box. Mainly a scale, right? Now here I want you to pause the video and pick up your compass box as well as notebook and be ready. Along with the instructions given in the video, you have to draw, and that will be good practice for you. And here we go. What we have to do is take help of the lines of a notebook. Already you find lines there, so make use of that. Use your scale and draw a straight line. Now we should have a protractor. With the help of protractor, we have to draw the curve. Keep protractor properly and draw the curve. And why did we draw the curve? Because that is the curve we are converting it to a concave mirror. Now bring back the scale. Let us draw incident ray. Now instead of drawing so many incident rays, let us take only one incident ray. And again here you have to make use of the line which is already there on your notebook and draw incident ray. And when you draw incident ray, remember you have to end that ray with the arrow mark. Look at this here, there is an arrow mark, and then only we can call this as a light ray, or else it is simply a line. And where this will reflect, we have seen in the demonstration as well as in the animation that it converge. It will reflect inward. And so we have to keep our scale and draw the reflected ray. And again when you draw the reflected ray, show an arrow mark on that reflected ray. Let us take one more incident ray at the bottom. And here we have to draw again an incident ray just like as how we have drawn on the top, and that incident ray falls on the concave mirror and reflect, right, backward. And when it reflects, it has to follow law of reflection. Now, is our scale properly placed? No, not at all. We have to place it properly, because we know that reflected ray of both these lines will pass through a single point. Point to be noted here, that the light rays which are parallel, understood, they have passed through a single point. We'll come back to this discussion little later, right? Now, this is what the diagram for convergence of light rays in the concave mirror. You can draw only two light rays, not so many light rays as it was shown in the animation. The point where these two rays meet is called principal focus of concave mirror. This is the concave mirror. Remember this. This is very important concept. So what is principal focus of concave mirror? The point where the light rays meet here right on your screen. The center of the mirror here is called pole. And if you can find an axis there, this is the axis which passed through. It's not a ray. We call it as an axis, and we'll referring it as principal axis, right? And why we need principal axis now? We need principal axis to refer these incident rays. Now I can tell incident rays which are parallel to the principal axis, this is principal axis, reflect back and pass through single point on the principal axis. I hope you have understood. So if you can draw this much, this is the diagram for convergence of light rays in the concave mirror. Suppose if a question is define principal focus. What you have seen in the previous slide is a principal focus. And if the question is define principal focus of concave mirror with the help of diagram, then you have to draw the same diagram and write at the bottom, you can read here, light rays parallel to the principal axis. These two are the light rays which are parallel to the principal axis. On reflection, they pass through a single point on principal axis, and this point is called as principal focus. So this is the answer for a definition of principal focus of concave mirror with the help of diagram, right? In the next video we shall see how can we define principal focus of convex mirror, right? Till then, stay fit, stay healthy. Thank you very much. Right? The next thing is keep a protector, but this is not the way how I have to keep the protector, because I am going to draw now a convex mirror, and convex mirror I can draw even by keeping like this, but then I have to keep properly, right? And then draw a curve. Now did you understand why did I use a protractor to draw divergence of light here to draw the convex mirror, right? Well, then you have to show that it's a mirror, so you have to shade it on one side. That indicates it's a rough side. It doesn't give any image on that side. It's a back side of the image, whereas this is the front side of the image. And every mirror will have a center point here. It's called pole of the mirror here, right? So this is pole of the mirror. So when you are working on your notebook now, pause this video, draw this, and then go to the next step. Okay, so what I'll do is I'll write pole here. Okay, and then this axis which you have seen right in front of you, this is the axis called principal axis. Recall the previous video of principal axis of concave mirror, right? So I'll write principal axis here. Now let me take two light rays parallel to the principal axis, one above here, another is here. So again I am using these lines, right? So let me keep this scale back and draw the light ray, and at the bottom also let me keep the scale right on that line which is already there on the ruled paper and draw a straight line. So these two are the incident rays, and you have seen already during the start of this video how will they reflect, right? You can refer, go back and see how will they reflect, they diverge. But to draw a rays which are diverged, I have taken a reference point here. Look at this reference point, right? So why that reference point is because I am going to keep this scale here right on that reference point, one end here, and the second edge, the same scale should move along with this point of incident and the reference point, and now I am ready to draw the reflected ray, and reflected ray will go back here and in this direction. Okay, so reflected ray is done. In the same way, keeping this as a reference point, down below we have to draw reflected ray. Now you can see this convex mirror, right? Convex mirror, and these are the rays which have diverged after reflection from the convex mirror, right? Now diagram is not yet over. When these reflected light rays are brought back, suppose if you can bring back these reflected light rays, will they not pass through this point? Surely, and that we have to do it. But reflected light rays cannot be brought back because it's an opaque body here. So the direction I can show, I am keeping again back this and show that with the help of a dotted line. That means it is just a direction here. Okay. In the same way, I am keeping this way here the scale right on these 2 points and draw this here. So I can tell you now that when they are extended back, they appear to meet on a point on the principal axis, and that is the point which is called principal focus, right? Well, we shall end here and take a few more diagram for practice in the next tutorial. Till then, thank you very much.